All right, so now we're going to be solving trig equations. This is kind of the culmination of everything we've done. Why do we care about being able to simplify and verify trig identities using the unit circle? Yeah, and the algebra again. So let's begin. All right, some strategies. We want to usually try to isolate trig functions, which means just get one trig function on one side of the equation. We're definitely going to use algebra, so factoring, multiplying, combining like terms, simplifying an equation, and use our trig identities to try to convert to one type of trig function. We're not always going to be able to do all of these things, but these are the strategies to kind of help us. So let's look at what do we do. First thing, solve this equation. 2x plus 1 equals 0. Pause the video, solve that equation, unpause when you're ready to discuss. Okay, so what'd you get? Hopefully negative 1/2. That's what I got. So how do we do that? Well, subtract the 1, divide by 2, right? Really basic algebra equation, solving a linear equation. So why did I put that here? Well, what do you think we're going to do first when we're solving a trig equation? Well, we're going to try to isolate the trig function. So I'm going to subtract the 1, and then I'm going to divide by the 2. Now, this is something we've seen before, right? Remember when we just had unit circle problems, and I said find all of the values between 0 and 2 pi or 0 and 360 where sine of x equals negative 1/2? That's what this problem is now, right? And so that's also why we had this restriction. So we had the restriction of 0 to 2 pi, including the 0, not including the 2 pi, because otherwise there's an infinite amount of answers. Same as those unit circle problems we did before. So think about our unit circle. We think about, okay, how does sine relate to the coordinates on the unit circle? Sine is the y coordinate, where the y coordinate's negative 1/2. I know I want my answers in radians because these are radians. So x equals 7 pi over 6 and 11 pi over 6. That's it. That's solving a trig equation, right? First part was algebra. Second part was using the unit circle. Let's try another one. Pause the video, solve 3x squared minus 1 equals 0. Unpause when you're ready to check that. All right, so here, hopefully you got plus or minus 1 over root 3 or plus or minus root 3 over 3. The biggest thing to remember is the plus or minus. So what did I do? I added 1, I divided by 3, and then I had x squared equals 1/3. But now I need to take the square root of both sides. But when I do that, I have to remember the plus and minus because both of those are going to be valid solutions. So I end up with x equals plus or minus 1 over root 3 or plus or minus root 3 over 3, depending on if I rationalize or not. Okay, so what are we going to do here? Add the 1, divide by 3. So I'm just going to do that all in one step. So cotangent squared of x equals 1/3. Take the square root of both sides. And I'm going to end up with cotangent of x equals plus or minus root 3 over 3. Now, that's not my answer. I have to think about the unit circle. So I want you to do this because this is something you've done before, and so this is good practice. So figure out which angles on the unit circle is cotangent going to have an answer of root 3 over 3. Or 1 over root 3. It doesn't matter how you think about it. Now notice the plus or minus. So that actually tells us we're going to have 4 answers here, because there's going to be 2 answers where cotangent will be positive, and there will be 2 answers where cotangent is negative. But, again, my hint to you is if we understand reference angles, if we find one of those answers, it should be really easy to find the other 3. So pause the video, find those on the unit circle, unpause when you're ready to discuss. Alright, so hopefully you got pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Now, again, some strategies to help you come up with that. If you were a little bit confused, okay, I think about how does cotangent relate to the coordinates on the unit circle. Cotangent is x divided by y. So if the root 3 is in the denominator to start, then I need the y coordinate to have the root 3 to start. That's my thought process. So I know 1/2 needs to be the x, and root 3 over 2 needs to be the y. And then if I do the algebra, or I'm sorry, the arithmetic, 1/2 over root 3 over 2, and I simplify, I'm going to get 1 over root 3, which is the same as root 3 over 3. That happens at all of the pi third angles. Next one. I want you to try, well, let's do the first part together, or try x squared minus 1 equals 0. Solve, pause the video, unpause when you're ready to check. Okay, so hopefully you got x equals plus or minus 1. Again, I added the 1, took the square root. I need to remember plus or minus, so I get x equals plus or minus 1 because the square root of 1 is 1. Okay, what I started to say before was I want you to actually try this whole thing on your own now that we've seen a couple of examples. So you've got secant squared of x minus 1 equals 0. Solve, find the values of x. Pause, unpause when you're ready to check. All right, so hopefully you got 0 and pi. How do we come up with that? Well, again, I added the 1, took the square root, so I get secant of x equals plus or minus 1. How does secant relate to the coordinates on the unit circle? Secant's the reciprocal of the x value. But if I get 1, the reciprocal of 1 is still 1. So where do the x values have where the x coordinates have a value of 1 or negative 1? That is at 0 for the positive 1 and at pi for the negative 1. Remember, we are not including 2 pi in here because we don't want redundancy. Okay, next one. I've got 2 trig functions now. Now what do I do? Well, let's do a little bit of algebra first. So remember, one of our strategies is get all the trig functions on one side. There's a couple of ways I can go about doing this. I'm going to use division though. And again, I have options. I could divide both sides by sine squared of x, or I could divide both sides by cosine squared of x. I'm going to divide both sides by cosine squared of x. It does not matter, but that's my choice. So I get sine squared of x over cosine squared of x equals 3. But this is where the trig comes in. What is sine over cosine? Well, that's tangent, so sine squared of x over cosine squared of x is tangent squared of x. Now, this looks like something that I've done before. Let's take the square root of both sides, and we get tangent of x equals plus or minus root 3. I want you to use your unit circle, pause the video, find where does tangent equal root 3 and negative root 3. Unpause when you're ready to check. So you might notice these are the same exact answers we got when cotangent of x was root 3 over 3, plus or minus. Because I know tangent is y divided by x, so I'm thinking about, well, if I just have a root 3, that means I did not rationalize. So I need the root 3 to start out in the numerator, so I need the y coordinate to have a root 3 in it, so I'm looking for all of the coordinates where the x is 1/2 and the y is root 3 over 2, but I want the positive and the negative, so that's pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Next one. I want you to try this on your own. This is going to be a little bit of a challenge, probably. But think about our strategies. So we have 2 different trig functions on 2 different sides of the equation. We talked about maybe getting everything on one side, maybe getting everything in terms of one trig function. See what you can do. If you get stuck, you can always unpause and hear my explanation. So pause the video, try it on your own, unpause when you're ready to check. Alright, so hopefully we got x equals pi halves and 3 pi halves, and x equals 2 pi thirds and 4 pi thirds, or x equals all of those. How did I come up with that though? Okay, so a few things going on here. One, remember I said we want to try to get this all in terms of one trig function if we can. So I have a cosine and I have a sine squared. Now in my head, I'm thinking to myself, it's not super easy just to change cosine of x into sine of x. But I do have an identity that conveniently changed sine squared of x into 1 minus cosine squared of x. So that's what I'm going to do. That way I can get everything in terms of cosine. So I changed sine squared of x into 1 minus cosine squared of x. This 2 right here stayed right there. Now the other thing I did in this first step was I thought from an algebra standpoint, a lot of times when I'm solving equations, if I have multiple terms with the variable in them, usually it helps to get everything on one side of the equation and get the equation equal to 0. Not always, but that's a decent strategy. So I also subtracted the cosine of x and I subtracted the 2. That's where these ended up, and that's why the equation equals 0. In my next step, distribute the 2 here, so I get 2 minus 2 cosine squared of x, Still have minus cosine of x minus 2 equals 0. Conveniently, look at this. The 2 and the negative 2, those go away, right? They cancel each other out. That becomes 0. So now I have negative 2 cosine squared of x minus cosine of x equals 0. So what do I do in algebra when I have a square term and a non-square term? I try to factor if I can. So here I took out a common factor, or the greatest common factor, which I thought of as negative cosine of x. So I factored out a negative cosine of x, and that left me here with 2 cosine of x. This term became plus 1. Since the equation equals 0, and I factored, I can set each factor equal to 0. So now I work two separate little equations. So negative cosine of x equals 0. If I divide both sides by negative 1, cosine of x equals 0. Here, 2 cosine of x plus 1 equals 0. Subtract 1, divide by 2, so cosine of x equals negative 1/2. Now I go to my unit circle. Where does cosine equal 0? When the x-coordinates are 0, which is at pi halves and 3 pi halves. Where does cosine of x equal negative 1/2? When the x-coordinate is negative 1/2, which is at 2 pi thirds and 4 pi thirds. That's solving trig equations.